Today we will discuss about the bevel gear and bevel gear terminology and the design procedure of bevel gear. So with the help of design procedure we can design a bevel gear and solve numerical problems on bevel gear. Okay, and the bevel gear is also explained with the help of flowchart, and we also compare different gears which we earlier discussed, that is spur gear, helical gear and bevel gear. What are the difference between these three? So first of all, what is bevel gear? So students, bevel gear is the gear which transmit motion or power between intersecting shafts, which are non-parallel. Okay, so this gear is helpful in transmitting the power or motion between intersecting shafts only. That not help in transmitting powers between parallel shafts. Okay. So as you seen in this picture of presentation, that this is the bevel gear. Okay, so it may transmit power at an right angle, that means at 90 degree, at 60 degree, 70 degree. So it may be helpful in transmitting power at certain angles. Okay, so this finds most applications in automobiles and many more other places. So next is gear terminology. So what is gear terminology? We already discussed about the gear terminology, but in the bevel gear terminology there are certain different things also arises. So first is, in the given picture there is yellow color showing bevel pinion pitch surface, where green color showing bevel gear pitch surface. So the green color showing pitch surface and the yellow color showing pitch surface of pinion. Okay, so as you know that pinion has the shorter in size and the gear has the larger in size. Okay, so there is a dotted line showing that the teeth on the gear is in the line of teeth on the pinion. Okay, so dotted line showing that, and also a long dotted line showing that the axis of the gear is in intersecting with the axis of the pinion. So this point, meeting point, is known as the center point or center cone, we can see that, or it is also known as the apex, pitch apex. Okay, so in the next we will show you about the pitch apex, which is the one of the gear dimensions about the bevel gear. Next is pitch apex. What is pitch apex? Pitch apex is the intersection of bevel gear pitch surface, bevel gear pitch surface with its axis is called pitch apex. Okay, we can say in the simple form is that intersection of bevel gear pitch surface with its axis of the shaft is called pitch apex. Okay, the diagram showing you about the pitch apex. There is a pinion also and a gear also. So the intersection of bevel surface as well as intersection of the pinion surface with its axis is known as pitch apex. Okay, next is front angle, face angle, root angle, pitch angle and back angle and the front angle. So students, in the given figure, the front angle is the angle between the front of the tooth and the vertical. Similarly, the back angle is the angle between the back of the tooth and the vertical is known as back angle as shown in the figure, and the angle between root of the tooth and the axis of the shaft is known as root angle, and similarly the pitch angle is the pitch of the gear tooth and the axis of the shaft is known as pitch angle. The angle between face of the tooth and the axis of the shaft is known as pitch angle. So you may get the better idea by showing this figure and you may understand about it. Next is mounting distance, total length, length of bore and crown to back length and hub width. So this figure show you about the mounting distance, about the bevel gear, total length. What is the total length? So total length is the length from the starting of the bevel gear to the end of the hub. Similarly, length of the bore is the dimensions or length of the bore in which the shaft is attached to the bevel gear. Similarly, hub length is the length of the hub mount created on the bevel gear. Okay. Next is the tooth face width. Tooth face width is the width of the face of the tooth, is known as tooth face width as shown in the figure. Addendum is the radial distance from the pitch line to the root of the addendum or to the top of the addendum or face of the addendum. So we can say that the distance, radial distance between pitch line to the face is known as addendum, and similarly the distance between radial distance between the pitch line to the root of the tooth is known as dedendum, and the complete whole distance between face to root is known as whole depth. Okay, so next is face cone, root cone, back cone and front cone. So and the face cone, as we earlier discussed also in the last diagram or previous pictures, face cone is the cone made by the face of the tooth to the axis of the shaft. Similarly, root cone is the cone made by the root of the tooth with the axis of the shaft, and the front cone is the cone made by the front of the teeth with the axis, and back cone is the back cone made by the back of the tooth with the axis, is known as back cone, or back of the bevel gear made with the axis is called back cone. So next is the dimensions of tooth of bevel gear. So certain points are known as toe points, as shown in figure. There is a toe in the front, there is a heel in the back, there is a peak on the top of the gear tooth, there is a face of tooth, flank of tooth, there is a outer end of the tooth, there is inner end, there is bottom, and there is also a pitch line is showing in the circular portion. That is the pitch line that is passes through the whole bevel gear. Next is your starting, or we can say that first flowchart diagram, with the help of which we can understand about the design procedure of helical gear. This design procedure is designed for helical gear only. Okay, but you know that the design procedure of all the gears are similar, so we can understand about the design procedure of spur gear, helical gear as well as bevel gear. Okay, there are certain changes, and these changes are introduced by the helix angle in helical gear, and there is a pitch cone angle in the bevel gear. So these changes are also discussed later in our session. So in this diagram, one point there is inputs, that is P is power, NP is speed of pinion, and G is gear ratio. So in the question statement, these are mentions, or they may be given in the statement. In the second point, there is a few angles about the pressure angle, then J is helix angle, and ZP is actual teeth on the pinion. Similarly, Z dash is virtual teeth on the pinion. And there is ZG is actual teeth of gear, and Z dash G is virtual teeth of gear, and SUP is ultimate tensile strength of the pinion, SUG is ultimate tensile strength of the gear. So in the first point there is a inputs. In the second point we have to select about the angles and the ultimate tensile strengths of the gear and pinion, and we also measure the Brinell hardness number from the data design book. We have also make or select the factor of safety regarding the term and conditions. We have taking service factor from the data design book. We have also take load distribution factor, okay, and we can assume it from the data design book. This is the second point. In the third point we have to calculate the bending stress for pinion, bending stress for gear, that means sigma BP and sigma BG. So sigma BP is bending stress for pinion and sigma BG is bending stress for gear, and we also calculate the Leves form factor for pinion and gear in the third step. In the after third step we have check which one is the weaker section. Is the value for pinion is weaker, or is the value for gear is weaker? We have to check the calculations, which one is the smaller one. Is the calculation from the pinion is smaller, or is the calculation from the gear is smaller? So after checking the weaker section we may design the weaker section only. You know that the gear and pinion both are made of same material, then the pinion is the weaker section. If the gear and pinion are made of different material, then we have to calculate these values, and we may find from the calculations which have the lesser value. Which have the lesser value, then we design for the same. So after finding the weaker section, we have to calculate the bending strength, or we can say that we have to find the bending strength FB, or FB is also equal to tangential tooth load, that is WT. So FB is equal to, what is the formula for FB or WT? That is sigma BP if the pinion is weaker. Sigma BP into B, that is face width, into MN is a module, normal module, and Y dash P, again Y dash P is a Leves form factor. Okay, so Y dash P, the formula for Y dash P is mentioned in your data design book. So these up to this point, the design procedure for spur gear and design procedure for the helical gear is same, and similarly the design procedure for the bevel gear is also same, but there are certain changes in these formulas or formulations that are mentioned in your data design book. So this is stage number 3. After finding these bending strength, we have go for the calculation of wear strength, or we can say that FW, or wear load. So FW is also, we can write it as WW, wear load, or in some books it may be mentioned as FW. Okay, so FW is equal to DP, that is DP is pitch circle diameter for pinion, and face width. BQ is ratio factor, and K is a load stress factor, and J is again the helix angle. As I already mentioned you that this flowchart is for helical gear, so J is used for helix angle. Next is calculations, that is the calculation for the pitch line velocity, that is V. So V is equal to pi dn upon 60. So which one is weaker section we have to calculate for the pitch line velocity. If pinion is weaker, then we have to find out pi dp np divided by 60, okay, and multiplied by 1000 for finding the value in the meter per second. Okay, similarly we have to next calculate about the ft. Ft is also, you know that what is ft. Ft is tangential tooth load, that is also equal to fb. So Ft is equal to P divided by V. P is power transmitted by the gear divided by V. V is again pitch line velocity, which we have measured by pi dn upon 60. So after measuring the WT, or theoretical tangential tooth force, or theoretical tangential tooth load, calculate for the velocity factor, that is denoted by KV, but in some books velocity factor is denoted by capital CV also. So CV, and the value of CV is also taken from the formula for CV or KV is taken from data design book, that is according to the term and conditions. Okay, after finding these values, we have to calculate the F effective. Okay, F effective is the effective load on the tooth of the gear. Okay, and F effective is equal to KA KM into FT divided by KV. Okay, so you know that Ka is already mentions, Ka is service factor and Km is a load distribution factor. Okay, so after calculating these values, F effective load, we have go for stage number 3, that is from finding F effective, we have to check that FB is lower than FW, or is it greater than FW. If FB yani ki bear strength, that means bear strength is less than wear strength or wear load, then we have design based on beam strength. Okay, and if FB is or we can say that FW is greater than FB, then we have to design on the basis of wear strength. Okay, consider that FB is lesser than FW, then we have to design based on beam strength, and we have to find out FB is equal to factor of safety multiplied by F effective. And what is F effective? Effective load on the tooth. So by calculating this value in the hit and trial method, and we get the answer. And similarly, if this condition is not true, that means FW is greater than FB, then we have to design for based on wear strength, and we have to find out FW is equal to factor of safety multiplied by F effective, and that is comparable with FW, and calculating the answer with the help of weight and trial method. So after finding the answer, we can go for the next standard module, okay, that is MN standard module, and calculate the value of MT, DP, DG and B and HA and HF. You know that what is MT, DP? MT is, you know, that transverse module. DP is the pitch circle diameter for pinion. DG is pitch circle diameter for gear. B is face width. HA is addendum and HF is dedendum. Okay. So after finding these values, calculate numerical values, that is FT, FB and FW. FT is, you know that what is FT, tangential tooth load. FB is beam strength and FW is wear load. Okay, and by finding these values, calculations for the FD, that is dynamic tooth load, or we can say that by Buckingham equation. Dynamic tooth load is taken by the Buckingham equation, and after finding the FD, go for calculation of F effective again. And what is the formula for F effective? F effective is equal to Ka Km into FT plus FD. From this formula we will get again a question is arises, that is FB is greater than or less than FW. If the FB is less than FW, then we have the design is safe, or we go for the FB is greater than NF or F effective. So FB is must be equal to or greater than factor of safety multiplied by F effective. If this condition is satisfied, then our gear pair is safe. And if the FW is greater than FB, then we go for FW must be greater than or equal to factor of safety multiplied by F effective. Then our design is also safe if this condition is satisfied. If this condition is not satisfied, these conditions are not satisfied, then we again go for the unsafe gear pair, unsafe against fitting, and gear pair unsafe against bending, and we again start our process by increasing the MN, that is Norman module, or by selecting stronger material, or by increasing face width, or by increasing accuracy of pinion and gear tooth, or by increasing the Brinell hardness number, face width, and similarly accuracy of pinion. So this is the flow chart for helical gear. These 2 pages show you the design procedure for helical gear, or this is most helpful in every numericals. So this procedure is followed in Spur gear, this procedure followed in bevel gear. But as I already told you that there is some changes in formulations, and these formulations you have already with you, that is in your data design book. So you can check and apply this flowchart, and you may get the easy answer for your numerical problem. So students, in the next topic we have design procedure of bevel gear. So what is the design procedure for bevel gear? You already know that first of all we have to design the bevel gear from beam strength. So what is beam strength? So beam strength, it is the maximum tangential tooth load that bevel tooth can take at large end without tooth breakage. So what is beam strength? It is the maximum tangential load that bevel tooth can take at large end without tooth breakage, that is known as beam strength. And the formula for beam strength is equal to sigma b dot b dot m dot y bracket 1 minus b divided by a naught bracket closed, where a naught is a pitch cone distance. And what is pitch cone distance? It is the distance from the pitch apex to the face of the tooth. Okay, that distance is known as the pitch apex, or sorry, pitch cone distance, a naught. Okay, and sigma b, already told you about the beam stress. Sigma b is the beam stress and is equal to ultimate tensile strength divided by 3. If in the question statement ultimate tensile strength is given, then we may find the beam bending stress by dividing it with the help of 3. So next is B is the face width, and if the value of face width is not given, then we may find it by a naught divided by 3 or by 10 m. Which one is lesser we will take for the face width, where m is the module. Okay, so this is the first step. In second step we have to find the Leves form factor. And what is Leves form factor? You already know that Leves form factor is taken from Leves equation, and the formula for Leves factor is also mentioned in your data design book. We have to take the value of Leves form factor according to the conditions. If the angle is given 20° full depth, then we will take this first formula, that is 0.484 minus 2.87 divided by TE, where TE is a equivalent number of teeth or virtual number of teeth. Similarly, if the angle is 14.5° full depth involute, then we will take this 0.39 minus 2.15 divided by equivalent number of teeth, where TE is equivalent number of teeth, or we can say that virtual number of teeth. And the value of equivalent number of teeth is finding by if we can design for pinion, then the teeth of pinion divided by cos of bevel angle. Okay, cos of bevel angle for pinion. Okay. Similarly, check for wicker section. After finding the Leves form factor, we have to check for the wicker section which one is wicker, gear or pinion. If the material for the gear and pinion is same, then design for pinion only, and if the material for gear and pinion are different, then design for the wicker one. After finding the Leves form factor, then find the wear strength, and the formula for wear strength is, or what is the wear strength? It is the maximum tangential load a bevel gear can take at large end without pitting failure. And what is pitting failure? We already discussed about the causes of gear failure. What is pitting failure? In pitting failure, there is a surface failure, or surface of the tooth may fails, is known as pitting failure. So for the formula for wear strength or wear load, that is WW or FW is equal to dp dot q dot b dot k, where dp is the pitch circle diameter for pinion if we design for pinion, q is the ratio factor, b is the face width, and k is the load stress factor. Okay, so there is the formula for q also, different formula for q, b formula for b is also, and formula for k is load stress factor. So for bevel gear, we will take the formulations from the data design book. Okay, and we will mention and we will find the wear strength. After finding the wear strength, we will find the effective load. That is how we can find out the effective load. We can find out effective load by two methods, that is preliminary estimation by velocity factor and precise estimation by Buckingham equation. So F effective is known as effective load on the tooth is equal to Ft maximum divided by Cv, and similarly precise estimation by Buckingham equation, that is F effective is equal to Ft maximum plus Fd. So students, where Ft maximum is equal to Ka Km into Ft, and Ft is, you know that what is Ft, tangential tooth load, Ka is a service factor, Km is a tooth load factor, and Fd, you know that Fd is a dynamic load, Cv is a velocity factor, and you already know that Ft is also finding by P by V into service factor, or that is Cs. So Ka and Cs is same. Ka is a service factor and Cs is also known as service factor. So students, this is the design procedure for bevel gear. I hope you may understand the complete concept about the spur gear, helical gear as well as bevel gear. In the next session, we will discuss about the numerical problem on bevel gear. With the help of these numerical problems, you may get the better idea how to design a bevel gear. Till then, thank you and bye. Practice your numerical problems in your notebook more and more for your theoretical, better preparation for theoretical exam. Thank you. Till then, bye.